This is the third lesson of our AS induction work, AS, the crossover between GCSE and Core 1. And we've looked at some gradients work, so today we're going to look at equations of lines and lots of different ways of getting the equations of straight lines. Lots of repeated exercises here with a little skill each time, building it up bit by bit. We'll start with a recap of what we did last time as we did before, so have a look at those, push pause and try and get y all on its own for each of these, and if you can see the gradient of each line then do write it down. This first one we need to get the y all on its own, so we'll add the 8 and we'll take away those 3 x's, and so that one there has got a gradient of -3. Crosses at 8 as well. This one here, it's easiest just to add that to both sides. So we've got 4x plus 4 equals 2y, and then divide everything by 2. And so that one there has got a gradient of 2. This one here, get y on its own again. Let's just add that over to that side there. 3x squared plus 5 equals 5y. And then just divide everything by 5. So I've got 3/5 of x squared, and 5 divided by 5 is 1. And we'll have a nice debate about the gradient of that one there. The gradient is the number of x's, but we haven't got any x's there. We've got an x squared. So it's not a line. This is a curve, and we'll do that in a later piece of work. And this fraction one here, let's times everything by the bottom there. So we're going to times the x plus 5 up the top there. My next line is y take away 1 equals 2x add 10. 2 times x, 2 times 5 is 10. And then we'll add the 1 to both sides. And so our gradient of this one is 2, and our intercept for our y-axis is 11. Beginning today's work then is all about taking these straight lines. You remember from GCSE y equals mx plus c, and you know the gradient. The gradient is 4, and so we could figure out some other points on the line. So this one here, what's that? There's 1, 6. It's going up, something like this. It should be on the line there. And another point on the line might be if we go along 1, how far up are we going to go? We're going to go up 4, so that point there is 210. The next point up here would be 314. And more interestingly, the point down here would be 0, 2. So we can see that it's crossing at 2. This equation is y equals 4x add 2. At GCSE, we were given the gradient, so we wrote y equals mx plus c, and we put the 5 in. And then we were given a couple of numbers. We were given an x number, and we were given a y number, and we filled those in to try and find out what c was. Well, c here, take away the 10 from both sides, was -7. And so our answer was y equals 5x, because we had it earlier, -7, because we finished it there. Now, this took a number of lines of working, and was sort of bitty that we did one bit there, we did another bit there, then we write the answer. Now it's great and it works and it isn't a problem, but this new method is incredibly more successful. All the examiners' reports say this is the way to do it, and it just makes life a lot easier because you've only got the one thing to remember. This says y take away a y number equals gradient x take away an x number. And it means you can do everything all in one go. You put the gradient there like you did before. You put the x number there and you put the y number in there, and here's the answer. Y take away the y number equals gradient x take away the x number. And that is an answer. In Core 3 you could leave that like an answer of a straight line. It's finished. That is it. Right, we want to try and make it look a different way. We could just multiply out by 5. Look, here's that -10 that came up in the finding the c part. And we want to get rid of this -3. Well, we could add 3 to this. So I've actually done that in just 3 lines of working, whereas I think it was about 5 last time. And so throughout this lesson, I'd rather you used y take away the y number equals gradient x take away the x number. Maybe in class you'll have some more examples on how brilliant this formula is and where it can be used even more. Your job for these first ones there is there's 5 questions there. Could you find out the equation of each of these lines? Using y, take away the y number. Push pause while I do this. Y take away the y number equals gradient x take away the x number. Multiply it out and add the 7. I'm not going to do the rest of them. If you've paused, you've had time to do that. Here are all the answers to those 6 there. What about if they were parallel? Well, last time we said that parallel lines have exactly the same gradient. So if we've got this one here, we know that its gradient is 3. Well, now it's exactly the same as we just did. Y take away the y number equals gradient. X take away the x number. Multiply it out and add the 7 to both sides. And there's our answer. So we're now going to do another exercise working through those. Push pause while you do it. I'll do this first one. Look, it's got a gradient of 2 there. So m equals 2. Y take away the y number equals gradient x take away the x number. Multiply it out and tidy it up. So here's the answers to those 4. 4, 6. What am I on about? Wow, we haven't been given the gradient now. We don't know the gradient. We've got an x number and a y number, yeah, but we don't know the gradient. But in lesson 1, we worked out to find out the gradient, we need to work out how far up it's gone, which here it's 8, divided by how far along it's gone. And here we've gone along 2. So the gradient must be 4. So it's y take away the y number equals gradient x take away the x number. Let's multiply it out and add the 2. So y equals 4x take away 2 is our equation. Why did I use these 2 as my x and y number and not these 2? Let's find out. Let's do y take away this y number equals gradient x take away this x number. Multiply out again. You can see where this is going. Add the 10 to both sides. And of course, we've got exactly the same answer. It didn't matter which pair we used, but we had to use both pairs to try and find out initially that the gradient was 4. So here's another exercise. Try and find out the equations of each of these lines linking these. Push pause while you do it. That one there's going up 8, going along 2, a gradient of 4, and so y equals 4x add 1 is the equation. Bringing in fractions at the end here, trying to encourage you to use 13 over 2 and not 6.5. And the last ones of these, perpendicular. We met in the second lesson that if this one's got a gradient of 2, then the perpendicular would be the negative reciprocal of this. So it would be -1/2. That's why fractions are going to be so important here. So now we've got y take away our y number equals gradient x take away our x number. Now, to try and tidy this one up, we could leave it like this, but I'm going to get rid of this by getting rid of this divide by 2. To get rid of this divide by 2, I'm going to times this by 2. And that leaves me with this line here. And now I could times by this -1, multiply out the bracket. And what you did now, we'll have discussions on exam questions tell you how to leave it. Sometimes you might be asked to leave all the letters on one side, so take away 10 equals 0. We saw one of those as an alternative form. Or you might want to rearrange it and leave it as y equals mx plus c. Different ways of rearranging them. Here's the exercise for these to do. Push pause if you don't want to know that the gradient of that one will be -1/2. Or -1/5, or 4. Oh, -1's the gradient here. -1 over -1 is 1. This one here is going to have a gradient of -1/4. And this one here, you need to do quite a lot of work. Midpoints. Well, the midpoint of a line is halfway along and halfway up. If I just made up a value here, so we'll go for 111 and we'll go up here 315, then halfway along is halfway between 1 and 3. Well, that's obvious. That's just 2. And halfway between 11 and 15 may be less obvious. The quick way of working out what halfway between two numbers are is to add them up and divide it by 2. Halfway between 11 and 15 is 13. The other thing that we can sometimes do with these is actually try and find out how long the line is as well. And you'll see that that line there is going along 2 and it's going up 4. So you could use Pythagoras to figure out that this side here is the square root of 2 squared add 4 squared, or the square root of 20. And maybe when we've done some surds work, we'll talk about how you could tidy up the square root of 20. Could you find out the midpoints of each of these? And as a bonus, find the lengths of each of them as well. And finally, put everything together to find out something called the perpendicular bisector. The perpendicular bisector is the equation of the line that cuts straight through the middle of two other points. We're going to need to know what is that midpoint. We're going to need to know what is the gradient of this one so that we can work out the gradient of this one here. So let's look at this. This gradient here, it's going up 6. It's going along 4. So our gradient here was 6 divided by 4, which is 3/2. So the gradient we're going to have is the negative reciprocal of that, minus 2/3. The point it's going through is halfway between 10 and 14, that's 12. And halfway between 7 and 13, add those together is 20, half of 20 is 10. So the midpoint is 12/10. Y, take away the y number, equals gradient x, take away the x number. Leave it there or times it all by 3. Timesing that by 3 gets rid of the fraction. Multiply out the bracket. And maybe stick it all on the left-hand side. I say maybe because the question would have to tell you how it wants it to be left. If it just says find the equation of the perpendicular bisector, we've actually finished there. I've just been pausing while I worked out that it was going to be minus 54 on the end. There's another one for you to try here, but that's a pretty packed lesson and quite a long video. So if you did want to try any more from the book, then that would be extra bonus practice there. So that's the end of our third lesson of our induction work. And let's pause that there.